Have you ever had those days when your robot drives perfectly straight and then the next day it suddenly acts like it forgot how to drive? Well, if you want your robot to finally move exactly how you want, consistently, then the best solution right now is Pybricks in a drive-based function. So, firstly, let me explain what the Pybricks is. Pybricks is a custom framework that lets your LEGO Spike Prime run pure Python directly on a hub, and there is no Bluetooth delays, no disconnection, no random behavior, and even initialization speed is twice its regular Spike Prime app. Now, to install the firmware on your hub, make sure that you use micro USB, and with this cable, connect your hub with your laptop or PC. Then you need to go to their website, pybricks.com, and click the code. There you will see the window and the other information, but now you need to click to install Pybricks firmware. Then you will select your hub, minus Spike Prime, and then you will agree the license terms and condition. Then you will name your hub, let's name it Tidal Tumble. And when you click next, you will see the video and the tutorial. Then you will install it. Here is how Drivebase works. Drivebase automatically keeps both motors spinning at exactly the same speed. Left motor and right motor perfectly synchronized so the robot doesn't drift. Now let's go to the programming part. First, initialize your prime hub and define your left and right motors on ports, and make sure to check your rotation direction. Next, create a variable called Drivebase or something else, and this class requires 4 parameters to work correctly. First, pass in the left and right motors on ports, and next is wheel diameter. Enter the size of your wheels in millimeters. I'm using 62.4. And the last parameter is axle track. This is the distance in millimeters between your two wheels. I'll set mine to 165. Now you can configure the speed using the Drivebase settings. Here I'm setting the straight speed to 450, and now you can use the functions called Drivebase straight, which will actually drive your robot straight, and Drivebase turn to navigate your robot more easily. Let's move on. This time we're going for distance. We're using straight and sending the robot to 450 millimeters, and to control the stop we use Zen parameter again. We're setting this one to stop brake. Unlike coasting, the brake command isn't instantly lock the motors and giving you the fastest, most precise stop possible. Also, we need acceleration to make our movements more accurate and remove any jerky movements in the end and in the beginning. So inside the settings function, we're adding straight acceleration and setting it to 450. The next step is turn function. With turn command, we simply tell the angle in degrees. We'll set this to 90 for perfect right turn. To guarantee the sharpest stop right at 90 degrees, we're adding the Zen parameter again and setting it to stop brake. But the values of function may vary depending on your hub. It may be one more or one less, so don't forget about it. Now we've seen how accurate the Drivebase is, but we can make it even better using the built-in gyro sensor. Right after initializing your Drivebase, simply add this line, Drivebase use gyro true. Setting this to true tells the robot to use the internal gyro to constantly check and correct the headings while driving straight and turning. Now look at our final code. We've combined everything we learned today: straight drive, acceleration, turns, and using gyro. And with this function, you will make your robot more stable. As you can see, this is the result of our program.